everyone, in the last video we learned about Q equal to Ne, which tells us how many charges are there in something. Today we are going to talk about current. Don't worry if it sounds tricky, I'll make it easy to understand. Let's imagine two containers filled with water. Here they are. They are sitting separately for now, not touching each other. I have added water to the containers. The first one is filled with blue water, but not much of it, just a little at the bottom. The second one has pink water and it's almost full. Can you see the difference? Okay, now we connect the two containers with a pipe. Look at what happens. The water starts flowing from the pink side to the blue side. That is because water always tries to go from a higher level to a lower level. After a little while, both the containers now have the same amount of water. Look, no more water is flowing because the levels are equal. There's no reason for the water to move anywhere. Now, let us take this idea and see how it works with electricity. Imagine these two are metal plates. One plate is packed with a lot of tiny electrons. Protons are also there, but there are a lot of free electrons moving around. Another plate is there with fewer number of electrons. But here's the thing. Electrons love to move. So if we connect a cylindrical wire from one metallic plate to another, what will happen? They want to go from the crowded plate to the other one, where there is more space for them. So when we connect these two plates with a wire, the electron starts flowing, just like the water did. This flow of electrons is what we call electric current. So when two bodies at different potentials are connected by a conducting wire, the charge flows from one body to another until the potentials of both the bodies become equal. Potential means you can say until the charges or until the number of electrons becomes equal. The flow of electric charge from a body to another through a conductor is called electric current. Now, current can be defined as the quantity of electric charge flowing through a conductor in 1 second. Okay, so 1 second is very important. The current that the quantity of electric charge flowing through a conductor in 1 second is called a current. The quantity of charge is symbolized as Q. In 1 second, time is important. Here we are saying again and again. So the symbol of time is T and we know the symbol of current is I. Okay, so here the formula happens to be I equal to Q over T, Q divided by T. Why we have given Q divided by T? Let's look at the definition once again. Current is defined as the quantity of electric charge flowing through a conductor in 1 second is called current. It can be also defined as the quantity of electric charge flowing through a conductor per unit time is also called current. Again, we can write it as the rate of flow of electric charge through a conductor is called current. Oh my God, so many definitions, but all these things tell us the same thing. What is the thing? That is divided by time. This word per, it indicates divided by. Wherever you see per unit time, that means you can write divided by time. The word, the rate of flow of charge, the rate of flow of something, the rate of something can be indicated by this symbol divided by time. Okay, so since it is written the rate of flow of charge, so we will write Q over T. So that means current is defined as Q over T. Okay, so if it is defined as Q over T, previously we have known that Q is also defined as, Q can be equal to the number of electrons multiplied by the charge on one electron, that is Q equal to Ne. So can we substitute Q with Ne and write I equal to Ne by T? In place of Q we have written Ne. Alright. Now let's go to the units. We have already known before that unit of current is ampere, unit of charge is coulomb, and we have in the formula current. So unit of current is ampere. We can take that. Unit of charge is coulomb, we can take that, and also unit of time is second, that is the SI unit. So if we put the units in the formula, then we can say 1 ampere. So instead of I am putting 1 ampere. In place of Q, I am putting the unit of Q, that is coulomb. So 1 coulomb over, in place of T, I am putting the unit of T, that is second, 1 second. So I can easily say 1 ampere equal to 1 coulomb over 1 second, or it can be also written like this, 1 ampere equal to 1 C raised to minus 1. That is the way of writing coulomb per second. Let's look at the definition of 1 ampere. So when can we say that 1 ampere of current is flowing? 1 ampere of current is said to be flown when 1 coulomb charge flows through a conductor in 1 second. Now 1 ampere of current, ampere is a large unit. Okay, so 1 ampere is a large current in terms of practical use. Smaller units of current are there that we use practically. They are milliampere and microampere. So what is the relation between ampere, milliampere and microampere? Let's look at the relation. So 1 ampere equal to 10 raised to 3, I mean 1000 milliampere. So we can also write it as 1 milliampere equal to 10 raised to minus 3 ampere, and 1 microampere equal to 10 raised to minus 6 ampere. In the reverse way, we can also say 1 ampere equal to 10 raised to 6 microampere. Alright, now here's a question for you. How many electrons actually flow in practical? How many electrons flow through a wire in 1 second time, if it is said that this wire contains 1 ampere current? Okay, so how many electrons will be flowing through that wire in 1 second? So this is a mathematical problem. It is asked how many. So that means number of electrons is being asked. So we have to find out n, number of electrons n. In the question, we already have the information that the amount of current is 1 ampere. So I can be taken as 1 ampere, and the time is also given 1 second. Now we have to choose such a formula where we have I, n and t. We have chosen I equal to NE by T. Let's put the values. The value of I is 1. The value of n we do not know, we have to find out, and the value of E we already knew, we have to remember. I told you the charge on one electron is 1.6 into 10 raised to minus 19. Let's do the simple linear equation over here. Okay, I'm doing all the steps for you. So the denominator 1 from the right hand side goes to the left hand side and it becomes multiplied. So 1 into 1 will be 1. Silly thing to do. In the next, but the numerator in the right hand side will remain as it is in the right hand side. Okay. So in the next step, definitely 1 multiplied by 1 will be 1. So in the left hand side, we have 1. In the right hand side, we have n multiplied by 1.6 multiplied by 10 raised to minus 19. Okay, I have to tell this so many times. Please do it yourselves. Alright. In the next step, I'm just, for our convenience, I'm just interchanging the sides. We can easily do this in a linear equation. So I'm taking n multiplied by 1.6 multiplied by 10 raised to minus 19 in the left hand side, and the 1 we are taking to the right hand side. Why have we done this? Because we need to find out the value of n. So we have just kept n in the left hand side for our convenience. In the next step, n remains in the left hand side, and this term 1.6 into 10 to the power minus 19, we take this term to the right hand side. So this is a term that was multiplied with n in the left hand side. So when the whole term goes to right hand side, it gets divided with 1. So 1 divided by 1.6 into 10 to the power minus 19, we can do that. Now how to do this calculation? Does it seem complex? Let's make it easier. We will not do the division first. So the first thing we can do is, there is a negative index in our denominator. So we can just put it in the numerator by changing the sign of the index, changing the sign of the power. So 10 to the power minus 19 becomes 10 to the power 19 as it goes with our numerator. And 1.6 is kept in the denominator as it is. Fine. So what can we do now? Now I'm just making it simpler. 1.6, I have broken it into 16 by 10. The decimal is changed into fraction. This has become a bit complex fraction, but it indicates 1 divided by 16 by 10. So 1 divided by 16 by 10, if it's the fraction, according to fraction division, 1 divided by 16 by 10 tells us that it will become 1 multiplied by 10 by 16, the reciprocal of it. So 16 by 10 becomes 10 by 16. I have already multiplied 1 here and not written that. Alright, and 10 to the power 19 is as it is. Now we have to do the division, 10 divided by 16. So 10 divided by 16, how are you going to do that? For that, 10 will be in the dividend and 16 will be in the divisor. Now look at it, 10 is a smaller number. You are dividing a smaller number with a greater number. So even 16 times 1 is greater than 10. So what should we take? We should take 16 times 0. That is only less than 10. So we subtract 10 minus 0, we get 10. Then we can put a decimal point, and for that decimal point we can put a 0 beside 10. It becomes 100. 16 times how much is closest to 100? 16 times 6 is 96. So if we subtract, we get 4. Alright, we have already taken the decimal point. Now we can put a 0 beside 4. So 16 times 2 is 32. And if we subtract that, we get 8. And if we put 0 beside 8, it becomes 80. So 16 times 5 is 80. Alright, here the division terminates. So our quotient is 0.625. So in place of n, we can write n equal to 0.625 multiplied by 10 raised to 19. Okay, now there's a rule in physics that it's a conventional rule that you should put the decimal point next to one digit from the left, and that digit should not be 0. In this expression, we had decimal point next to one digit, but it was 0. So let us shift the point. Let us do one right shift so that the point comes after 6. That is a non-zero number. So it will become 6.25, but to do this right shift, what we need to do? We need to subtract 1. Since we are shifting one position, so we need to subtract 1 from the index of 10. So what will happen in our next step? In our next step, it will become 6.25 multiplied by 10 raised to 18. Okay, now 6.25 into 10 raised to 18 electrons. What does that mean? That means 6 to 5 and then 16 zeros. These many electrons actually need to flow through a wire in 1 second to make 1 ampere of current. Just 1 ampere of currents. Okay. So these are the number of electrons that needs to flow. Isn't it a large number flowing through a wire in just 1 second? Does that sound crazy? Okay, if it does, then take your time, think about it. If you have any questions or doubt, make sure to write it in the comment section, and see you on our next video. Till then, goodbye.